That'll be due next week.
Okay.
Yeah. So this Thursday for the first one. Next one will probably be Tuesday or Wednesday of next week.
9 sugar house.
And then we'll have an in-class quiz around there next week.
That's the one that we got.
And then we'll plan our test.
How long is the in-class quiz? Is it like a unit test or just like a quiz?
It's like half of a test as far as length, but it's intense.
Oh,
Yeah.
it sounds good.
Yeah, it sounds very good. So, today we are going to take what we learned about sine and cosine graphs and apply them to real life situations. I mentioned before, anything that repeats itself on a regular basis can be modeled by a sine and cosine graph. And this first one is talking about tides. Tides come in, tides go out, tides come in, tides go out, and so it makes an equation. And this is going to be the easiest type of word problem you can get, is when they give you the equation. So for us, this is just a practice of our DAB C. I'm going to just take this out here. Don't need this. So we're going to start. You guys did this in class yesterday. You did lots of graphing. How do we sketch a graph? We start with our D value. In this case though, and sometimes in real life problems, the numbers aren't as nice. So we've got a 13.7. So what I would do is somewhere on my y-axis, I'd write a 13.7. Draw a dotted line. I like to use a red pen for dotted line. That's going to be my sinusoidal axis. And I have successfully done the D part of DAB C. Next is the A. A says use your amplitude, which is 4.5, and label your maximum. So if I went up 4.5, that's going to be at 18.2, and down 4.5, 9.2. And I'm trying to approximate an appropriate scale. So I was like, yeah, maybe that's 4.5-ish along the way. And we've done the A part. Your B value finds your period. So here I'd have to do, my period is going to equal 2 pi divided by my B value, and my B value is 0.16 pi. This will require a calculator because of how the numbers are. I mean, you can probably see that the pi's are going to cancel out. And then you go to your calculator, and 2 divided by 0.16 is 12.5. So we mark a 12.5 somewhere along the x-axis and divide it into 4 equal sections. Half of 12.5 would be 6.25. Half of 6.25 would be 3.125. And 3 3.125s would be 9.375. That is your B value. Next, your dash, graph it without a shift. But you may notice in this graph that there is no shift, right? There's no plus or minus anything here inside the brackets. So we really don't have to do the dotted line because we can just go straight to our graph. This is a cos graph. Cos graph normally starts at a maximum, but since it's a negative cos graph, we are going to start at the minimum. And it will go minimum, center line, maximum, center line, minimum. Draw a nice smooth curve through each of those points and add your arrowheads. You've successfully drawn one period of this graph. So part B says this is a bulk carrier. This is a big ship. A big boat, a big ship needs at least 14.5 meters of water to dock safely. For how many hours per cycle can the bulk carrier dock safely? And I'm going to do, for those of you that are going on to AP Calculus, you're going to need to know how to use your calculator to solve this and how to do it algebraically. Okay? 14.5 is right here. You see that between this point and this point, the depth of the water is deeper than 14.5. Everywhere else, that ship would get stuck in the mud or whatever's at the bottom, the rocks, and have to wait until there was enough water that it could get out again. So this is the idea of this question. We're going to put this into our calculator. And a couple of things, typing it in is not going to be hard. So if you have a graphing calculator, and if you don't have a graphing calculator on your phone, which you can't take out right now, but this is for at home, you can download the Desmos app. I'll show you what the Desmos app looks like as well. But we'll start with our calculator. So I open up my calculator, I go to y equals, and I'm going to write negative 4.5 cos. I make sure that I'm in radians, which I am, 0.16 pi, and then my variable is going to be x. So you make sure you don't forget that variable, plus 13.7. So I write my equation in there, but if I just hit graph, it might look like this, because the window screen that normally shows up on your calculator goes from -10 to 10. What we want is we want to see this part of our graph. And because I graphed it by hand, you see that I need to look up to at least 18.2. When I went up to only 10, you can see why I only saw this little tiny bit of the graph. Also to the right, I want to go up to 12.5. The way that you can do that on a graphing calculator is hit your window button. And your window button lets you change what you look at your x's. So I'm just going to go from -1, I want to go up to 12.5. I'll go a little further. I'll go up to 15. And my y's, I'll go from -1. Usually I do 1 negative so I can still see the axes. But I needed to go up to 18.2, so I'll go up to 20. Now when I hit graph, I see very much what I saw on my whiteboard before. It looks very similar. Once you have that graph in, you can go to y, and in y2, if I want to draw a horizontal line at 14.5 meters, I just write y2 equals 14.5. That draws that straight line. And your graphing calculator has it built in to find out where graphs are intersecting. Everything on a graphing calculator is under this trace button. Above it, it says calculate. So I go second and then my trace button. And this lets me calculate things on my graph. I can calculate values, x-intercepts, minimums, maximums, intersection points, derivatives, and integrals, which you don't need to know yet. But I want to find out where they intersect number 5. So I push enter on that, push enter on my first curve, enter on my second curve, enter when it says guess, and one of them is at 9.019. The other one, if I want to find the other one, I do it again, and I would need to be closer. It'll always find the one that's closest. So once I get closer, it finds the other one at 3.481. This one, 3.481, and this one was 9.019. 3 decimal places, and I get the values. For those of you that don't have a graphing calculator, Desmos.com, you can go on the internet, you can download the app to have it on your phone, and you just write in the equation the same as we had, negative 4.5 cos bracket 0.16 pi, and sometimes this keyboard here lets you, there's pi, x bracket plus 13.7. Oops, plus 13.7. And of course I can't see it, but on this one I can just drag my screen. It's really nice. So Desmos has some things that are more user-friendly than a graphing calculator, in my opinion. I can just, in my number 2, I can y equals 14.5. Whoops. It draws it right away. And then it knows when you get close, it's like, oh, you probably want to find this point and this point, and you can just click on them, and it writes them down. We got the 9.019 again and the 3.481 again. So Desmos, really, really useful for figuring things out as well. And learning how to use it is helpful too, because in the AP Calculus course, you're allowed to use a graphing calculator, and on the exam, you have access to Desmos. So you can use both of them on your exam. Very powerful tools for figuring things out. Now, if you didn't have Desmos and didn't have a graphing calculator, and you were in a university class that required you to do this by hand, you could use your cast rule and all of the trigonometry we've done with one little trick and be fine for this as well. I'm going to put this in the video, but I will not give you enough time to write it down, so you can just watch. So if you were solving this algebraically, you know that the depth is 14.5. You plug that in for the depth, and now we have to solve for t. This is what you want to use your algebra skills to do. Okay, so what am I going to do? First, I'm going to get the cos by itself. So I move the 13.7 over, I divide by the negative 4.5, I get the cos by itself. And this would be a lot easier if there wasn't all of this stuff in here. In fact, if this was one nice big theta, wouldn't that be easier? Because then you'd say, oh, cast rule, I find my reference angle, and according to my reference angle, cos is negative. I have to look in quadrants 2 and quadrants 3. Perfect. Well, sometimes in math we do that. We say, if this would be way easier if this is a theta, well then temporarily I'm going to make it theta. Make it easier for myself. So if I did that, I could solve for theta. I could find my reference angle to be 1.392, and then I could find it in quadrant 2 and also in quadrant 3. Perfect. But now these are equal to the theta, and since theta was this, I can now substitute back. So that's the little trick. We temporarily substitute back and say if theta was 1.7495, then 0.16 pi t would be that. And if I divide by the 0.16 pi, sure enough, I get that 3.481. And I could do the same thing with the other one and get the 9.018 or 19. And so we can write a statement that we know maybe 1x. There we go. The ship is safe for about 5.54 hours. Question?
Can you just go back up a little bit?
To this slide here?
Yeah.
Okay. So what we did, we got cos by itself. We temporarily made a substitution to make our life easier because we knew how to solve cos theta questions with our cast rule, with our reference angles. And then once you've got theta, you go, oh, now I've done that part, I could substitute back and figure it out from there. Again, that is on the video. You can watch it later if you want to see. Will you be asked on your exam that difficulty on my test? No. Okay. Will you be expected to know how to do that in university? Yes. That's sometimes what happens. In one course, they don't expect you to know how to do it for the test. And you're like, okay, that's good. But then you move to the next level of course, and they're like, well, you should know how to do that. And you sort of have to pick that up in between. That sometimes happens from one course to the next, or from high school to university. So I show it to you so you could be prepared. Now, a more difficult word problem looks like this. They give you enough information to draw the graph, and if you can draw the graph, then you can find the equation. So here we have a Ferris wheel. Does everybody know what a Ferris wheel is? This is like you're at a fair, you've got one of these nice big wheels. Oh, that's a little bit too big. Right there, drag it down. It has spokes going to this, obviously, otherwise it'll fall off. And there's chairs. Oh, so much fun. So you can, as a person here, there we go. There's you, so happy. Oops. There we go. You can sit on a chair and you go around and around and around and around. Right? They can't make them go too fast, get sick. Whoa. Fall off your chair, that would not be good. Okay. So we need to graph this equation based on the information that we've done. So I've drawn the picture here, and with the picture here right beside it, I'm going to draw my x and my y axes. My x-axis is going to be the ground. Ferris wheel has a radius of 15 meters. It rotates once every 20 seconds. Passengers start at the bottom. Very good idea. Not good to like catapult them to start at the top. So they start at the bottom. Does it make sense then? If this is you at time 0, this is where you're getting on. And so we can draw that on the graph and say, if this is my time, and this is my height, at time 0, I'm going to be right here. That's, oops, that's there. And at what height would I get on? 1 meter above the ground. I can label that as 1. Does that make sense? So what else does it say? It rotates every 20 seconds. So I can put 20 seconds here. Where will I be after 20 seconds?
Back at the start.
Right back at the start. So I can add another dot. I'll be right there. Where will you be at 10 seconds? And maybe I would put in here my units, seconds. This is in meters. Where will you be at 10 seconds?
Maximum.
What is that maximum? You're going to be at the maximum. 10 seconds, you'd be halfway around, right? You'd be way up here. The most exciting and scary part of the Ferris wheel, right? You can see so much. You're so high above the ground.
31 meters.
31 meters. How did you figure out that this was going to be at 31?
Because it was double the radius.
The radius was 15. And this would be exactly double that radius, so 31 at 10 seconds. Can you see that this would be like one full period? Usually we divide our period into 4 equal sections, so I'm going to add 5 and 15. 5 seconds makes sense that you'd be right there. What height would that be? Right in the middle here. In fact, that's going to be our sinusoidal axis. At y equals, well, if the radius is 15 and you're up 1 plus 15, it's going to be 16. That's going to be a point here and here. And you keep on going. So since we have this, could you undo the DAB-C to create an equation? Because the question says, graph the function, and find its equation. So let's undo dab C. Can you tell me what the D value is based on the graph? Has to be 16. What's our amplitude based on the graph? 15. That's exactly the radius. Your period is 2 pi over your B value. Your B value is 2 pi over your period. Those are two important formulas. We don't know the B value, but from the graph we know the period. How long did it take to repeat itself? 20 seconds. So our B value is going to be 2 pi over 20. And I actually like not reducing that to pi over 10. I like leaving it as 2 pi over 20 because then I can see the period built right into that fraction. Now the C value changes depending on which graph you're looking at. So I'm going to start writing a graph. I'm going to say I want to start off with a sine graph. So if I started off with a sine graph, my A value would be 15 sine. My B value is 2 pi over 20. Bracket and factored. I don't have my C value yet, but my D value is 16. Where does a sine graph start? In the middle, going up. So I look on my graph. Where is it at the middle going up? 5 to the right. How do I show 5 to the right in an equation? Minus 5. What happens if you did a cos graph? And I hope you start to realize that the dab part, the D, well, not here. Negative sign in here. Leave that out. Your D value of 16, your A value of 15, your B value, which is from your period, those three stay the same for the most part. Sometimes your A value could be negative if you wanted to start at a minimum or in the middle going down, but the numbers will stay the same. Only thing that changes is your C value. If I wanted to do a cos graph, where does a cos graph start? At a maximum. Where is our nearest maximum? Right here. 10 to the right. How do I show 10 to the right? Minus 10. Probably my favorite one, if I was actually doing this graph, I would probably do a negative cos graph. Can you see with the negative cos graph there would be no shift? I think that makes the easiest equation. So when you're asked to write an equation, as in this question, you have options. If we have time, remind me, I'll tell you a Ferris wheel story at the end of class. If we have time. Okay. Estimate the height after 22 seconds. So if I went on here, I would say, this is an estimate, so I'm going to go, okay, 22 is right there. If I go up from that graph, I'd hit it there and go over. I have to come up with a number that I would guess. If you guessed anything over 16, you'd be obviously way off. I'm guessing maybe 4, maybe 5. Any of those estimates would be fine. If you wanted to actually find it, you could use Desmos or a graphing calculator and plug in 22. I'm not going to do that right now. I'm going to show you on the previous example that we already have in here. Okay. If I wanted to find a value, I can go to the calculate, second calculate a value. I think 22 is actually past my, I think I only went up to 20 or 15. So let's just pick a number. Say 7. Push enter. It tells me what it is. At 7, it's at 17.88. It's that easy to get the answers from your calculator. You can try 11. 10.41. You can put any number in. It will calculate the value if you put in a graph. So we estimated 4 meters, I don't know. We could actually type it into our calculator and find the exact value if we wanted to. But again, we're trying to save some time here because it's shortened periods to take. And maybe I'll get time to tell the story, which is probably more interesting. No, not more interesting. No. Estimate at what time you'll be above the ground at 20 meters. So I'll go back to my graph. 20 meters, I'll do it in purple here. I'm going to say 20 is about here. It'd be 20 meters here. I could say that number or that number. So maybe I say 6 seconds and 14 seconds. And again, just like we did in the last one with either Desmos or your graphing calculator, you could draw that horizontal line and find out where they intersect. So if you wanted to actually find it, what did we say, 6 seconds or 14 seconds? Because it says estimate. So as long as your answers are reasonable, you would be fine with that. Again, not typical that they'd have an estimate question on the final exam. They would want to be more precise. You're not allowed a graphing calculator on your exam, so you wouldn't be asked to do this kind of question because it would take too long. But it is something you need to know how to do well for the AP class next year, so it's important to sort of get a sense of it already. World's highest tides occur at the Bay of Fundy and are periodic in nature. So this means that it's repeating itself over a certain amount of time. As soon as they say that, you know you can make a sine or a cosine graph. And this question shows us the minimum amount of information you need to do that. If you have one minimum and one maximum, and they're consecutive, you can find the equation. So let's start just by drawing the information that's given. They tell us that a maximum depth of water of 8 meters, so this is going to be my maximum, 8, is measured at 4:30 a.m. So I'm going to mark here. Are you okay that 4:30 you won't write as 4.3? How would you write 4 if you wanted to do decimals along the bottom? 4.5. Because it's half an hour, right? So if we're measuring time here in hours, and this is our depth in meters, 4:30 would be 4.5. And I can add that dot, that's a maximum. And as a good real life example, I'm not using nice numbers. Oh, 6 hours and 12 minutes later, kind of nice numbers, you'll see in a bit, but at 10:42, it hits the minimum. So I'm going to make a mark along here. If this is 4.5, 10, it'll be about here. How would I write 1042 as a decimal? If 430 is 4.5, 1042 will be 10 point. How would you figure that out? Right? You could use the strategy of write something that's somewhat unreadable and hope the teacher gives you the benefit of the doubt. What number is that? No one knows. It's probably a 7, right? No. How do we figure it out? Well, how did you figure out 30 minutes? Well, you did this math without knowing it. 30 out of 60, right? That's 0.5. How would you do 42 out of 60? What is that as a decimal? You could type it into your calculator. You could divide them both by 6 and say, oh, I know 7/10 is 0.7. And get the decimal that way. That's going to be our minimum, and it's at 2 meters. So I'm going to mark on here, 2 meters, that's the minimum. If it's periodic, if it took 6.2 hours to get to the minimum, does it make sense that it would take another 6.2 hours to get back to the maximum. So I can mark on here another distance. This distance, another 6.2 will be at 16.9, and that's going to be. And then I can divide this into 4 equal sections. If this is 6.2, then this whole distance here, does it make sense? This whole distance from here to here is 12.4. Half of 6.2 is 3.1, so that'll give me to 7.6 and 13.8. And at those points, does it make sense? It would be right in the middle. Draw your sinusoidal axes. It's going to be at 5. And we would have a point here and here. And we have enough information to draw our graph. Can we undo dab C? Absolutely. You see that your D value, your center line is 5. What's our amplitude? Center to the maximum, center to the minimum, 3. Our B value is 2 pi over our period. And I'm going to leave it as a not nice number. 2 pi over 12.4. Technically, if this was an exam question, you're not allowed to have decimals inside of fractions. So you technically have to multiply the top and bottom by 10 and write 20 pi over 124 is okay. But 2 pi over 12.4 on the final exam would cause you to get an E error for not simplifying the fraction. You're not allowed decimals in fractions. Just another tiny bit of information. But for this one, we're going to leave it as a decimal. Then the C value changes depending on what you do. So if I were doing a sine graph, my A value is 3, sine. My B value is 2 pi over 12.4. I'm going to leave out my C value. I know that my D value is plus 5. Where does a sine graph start? In the middle, going up. Can I find a point in the middle going up? Yeah, there's one right there. Technically, you could go back to this one. You could choose either one of those. But since I have that other one labeled, I may as well do 13.8 to the right. That would be minus 13.8. That's one equation. Equation 2, I could do a cos graph. A would still be 3, cos 2 pi over 12.4. I'll leave my C value. D value is still 5. Where does the cos graph start? In purple. At a maximum. Yeah, I have a maximum. It's not purple. I have a maximum right there. What is that? 4.5 to the right? Minus 4.5. So when writing the equation, you have an infinite amount of answers. Hey, you want to make my life miserable? You could figure one out way down over here. Right? Figure out the math. Where would it be? You know, hours and hours and hours and hours later. And you could write that number. And you'd be like, haha, you have to check. And I'll just go, haha, I'll mark it wrong and they'll make you prove to me that it works. Probably not a good use of your time on a test because you'd have to work, but you could. I shouldn't give you ideas how to make teachers' lives miserable. This really sounds like it could backfire, but we could do. Okay, so this is a tides question. You've got 2 equations. Again, we figured out the 2 equations. We've done part A. Estimate the depth at 1:30 p.m. How do you translate this to 1:30? Where does 1:30 p.m. fit on my scale? What number would I write for 1:30? 1.5? Is this 1:30? 1.5? Well, that 1.5 would be 1:30 a.m. 13.5. You sort of have to go to a 24-hour clock, right? What would you estimate? 3.5, 4, anything in there would be fine. Again, if you wanted to find it exact, then you need a graphing calculator or Desmos. I guess technically a scientific calculator, you could take either of these equations and replace the x with 13.5. Push enter and you will get the answer. Because that's what you're doing. You're replacing the x value with 13.5 and wanting to know what the depth is. Does that ask us another estimate? No. Okay. So, that's where we're going to stop the video. There's 2 questions at the bottom there for you to try.